In this video, I'm going to show you how to analyze problems that involve inelastic collisions. This is where we have two masses that have their respective velocities. They collide, and then they stick together and move as one with some final velocity. I'm going to consider two problems in this video. The first one, here we have a bullet of mass m that's moving at some velocity. We don't know what it is yet, v, and it strikes a block of mass capital M that's hanging by some very light or massless string, and the bullet gets lodged into it, and then the block swings up to some height, h, from its initial position. So the goal is so if we're given this height h, the goal is to find the velocity v. Now we have to use conservation of energy and conservation of momentum to do this. So I'm going to show you, so first we write the energies. So the potential energy of the bullet moves purely horizontally. There's no, the potential energy is going to be 0. The kinetic energy is 1/2 mv squared. I'm going to label this 1, by the way, and this I'm going to label it 3. The potential energy, so when the block is at its highest point here, the potential energy is going to be the mass, which is with the bullet lodged into it, it's going to be little m plus big M times g times h. The kinetic energy at the top is going to be 0 because it's completely still at the point of when it reaches the highest point. Its kinetic energy is 0. And now you may be tempted to write to say that the potential energy of 1 plus kinetic energy of 1 is equal to potential energy at 3 plus kinetic energy at 3. And if you plug in the formulas here, we have 1/2 mv squared on the left equals little m plus big M gh on the right. And if we solve for v, that gives us v equals square root 2 times little m plus big M gh over little m. But this would be incorrect because in going from 1 to 3, there was an inelastic collision, and that means that mechanical energy is not conserved. Why is it not conserved? Well, because there is dissipative forces, there's heat involved that's not taken into account in this equation here. So let me show you what it is equal to, what PE1 plus KE1 is equal to. So this will be PE1 plus KE1. It would be equal to PE3 plus KE3 plus the work due to non-conservative forces. So when you have a bullet and you fire it at a block M, sparks will fly. That's heat. That is the result of an inelastic collision. It's just writing this does not take that into account, and so some of the energy is lost as a result of friction. So what do? We have to consider the collision itself at 2. So when the bullet collides with the block, it is going to, so as a collective, this is going to move with some different velocity. I'm going to call it lowercase u. And so yeah, the potential energy, the block has not raised yet. It's 0, and the kinetic energy is 1/2 times mu squared. We don't know what u is, but we can figure it out, because in going from 2 to 3, only gravity is the force that acts on the system. Gravity is a conservative force, and therefore mechanical energy is conserved. So we can write we can write PE1, PE2 plus KE2, the kinetic energy of 2, equals potential energy of 3 plus kinetic energy of 3. So in going from 2 to 3, the mechanical energy is conserved, and we can write the sum of these two equals the sum of these two. So this is going to be, let's see, 1/2 times mu squared equals m plus big M times g times h. Oh, hang on a second. I'm sorry. So instead of little m, this should be 1/2 little m plus big M, because at 2, the bullet is lodged into the block here. So the total mass, this should be 1/2 little m plus big M u squared. That is the initial kinetic energy of 2. So now we solve for u. So we divide both sides by little m plus big M. Multiply both sides. So u squared equals 2 gh, and u is going to be the square root of 2gh. And now that we know what u is, we can figure out what v is. Now, we cannot say that PE1 plus KE1 equals PE2 plus KE2 because there's an inelastic collision. However, conservation of momentum does apply whether the collision is inelastic or elastic. So I can write that, let's see, P1 equals P2. Now, what is the momentum of 1? It's going to be the mass times the velocity. So here, we're moving in one dimension. V is going to be in the same direction as u. So, so the mass of the bullet is going to be little m times v, and 2, the mass of the collective, of the blob, if you will, it's going to be little m plus big M times u. And now we can solve for v. So this is going to be v equals m plus big M over little m, and I'm going to substitute square root 2gh. So this will be the velocity of the bullet, and not this here. And so let's say that, so instead of, so let's say that we knew the mass or the velocity of the bullet, we could figure out what the height would be if we wanted to by solving this formula for h. And let's see, if we do that very quickly, that's going to be, so I'm going to multiply both sides by m over m plus big M, m over m plus big M, v equals square root 2gh. And so h is going to be 1 over 2g, and let's see, m plus capital M squared v squared. So this is if we know the velocity of the bullet and we want to find out how high the block rises from its initial position. This would be the formula for that. So yeah, this is the analysis for the bullet that hits a block and rises to some height. I'm going to consider one more example here, and that is another classic example. So what we have here are two cars that get into an accident here. So this first car, M1, is traveling north with speed V1. And we have another car, mass M2, that travels west with speed V2. And they crash, and they go on some trajectory. They have some final velocity VF, And the goal is to find the direction, theta, that they move at, as well as to find, let's see, the final velocity, as well as the work done by non-conservative forces like friction. So, what are the energies involved? So the potential energy is zero. The cars don't raise or lower. So for this car, car one, potential energy is zero. The kinetic energy is 1/2 times m1 v1 squared. Let's see, for car two, potential energy is zero. Kinetic energy is 1/2 m2 v2 squared. And the final energies, that's going to be potential energy is zero. Kinetic energy, that is 1/2 m1 plus m2 v final squared. We don't know what v final is yet, but we will figure it out. All right, so as I said, this is an inelastic collision, so mechanical energy is not conserved. So 1/2 m1 v1 squared plus 1/2 m2 v2 squared. This is not equal to 1/2 m1 plus m2 v final squared. We have to add plus w, where w is the work due to non-conservative forces, for the same reason that I explained earlier, that there is heat involved. Sparks are going to fly, and this conservation of energy holds. However, the conservation of mechanical energy does not hold. But anyway, with this formula, we can figure out what the work is, and but we don't know what VF is or theta. We can use conservation of momentum to figure those out. Because we're in two dimensions, we can figure out two unknowns, in this case, VF and theta. So it's important to recognize here that momentum is a vector, whereas energy is a scalar equation. Direction has to be taken into account when applying momentum. So the initial momentum, so I represent vectors with angled brackets like this, with the x-coordinate or the x-component separated by with the y-component by a comma. So for this first car, I should specify that the positive direction upward is positive, or north is in the positive y direction, and east is the positive x direction. So for a car that moves north, it's going to have zero. Its x component is zero for the velocity, and the momentum is going to be m1 v1. The velocity of the second car, it's traveling west. That is in the negative x direction. So that is going to be negative m2 times v2. And there's no, it's not moving vertically at all. So the y component of the second car's momentum is zero. Final momentum, that is going to be, let's see. So it's moving to the to the top left. So the x component will be negative, but the y component will be positive. So negative. The mass of the blob, that is going to be m1 plus m2, and the velocity is going to be the x component of the velocity. That's going to be vf sine theta. The reason it's sine theta is because the angle is with respect to the vertical. So if we multiply vf, the hypotenuse, by sine theta, that gives me the opposite, the x component of that vector. And And the y component, I'm out of space here, so I'm going to write it below it. So this is going to be positive m1 plus m2 vf cosine theta. And now I'm going to combine the two vectors on the left side of the equation. I add them component-wise. So 0 minus m2 v2, that is the x component on the left. So negative m2 v2. And then I add the y components now, m1 v1 plus 0. And this is equal to negative, so it's equal to the same thing, m1 plus m2 vf sine theta, and then m1 plus m2 vf cosine theta. Now that I have a vector equals vector, I can set the components equal to one another. So this vector equation implies two scalar equations. So this is going to be, so I have negative m2 v2 equals negative m1 plus m2 vf sine theta. And now I'm going to set the y components equal to each other. This is m1 v1 equals m1 plus m2 times vf cosine theta. Now, these are two equations, and we can figure out the two unknowns, vf and theta. So I'm going to start by multiplying both sides of the first equation by -1 to get rid of the minus sign here. So that's not an issue here. To solve for theta, I'm going to eliminate vf, and I do that by dividing the respective sides of these equations. So on the left side, I have m2 v2 divided by m1 v1 equals, and now I have m1 plus m2 vf sine theta over, this is going to be m1 plus m2 vf cosine theta. The vf's cancel out, and so does m1 plus m2. What's left is tangent theta on the right side equals m2 v2 over m1 v1, and this implies that theta is the inverse tangent of m2 v2 over m1 v1. Now, this is the direction that the cars travel in after the collision, and it's interesting to note that if m1 is equal to m2, if the cars have the same mass, and if they have the same velocity of v1 equals v2, then this is just 1, the fraction, and the inverse tangent of 1 is 45 degrees. So again, if the cars have the same mass and the same velocity, they will travel at a 45-degree angle to the northwest. So that's interesting that it simplifies like that. But yeah, that's so this is theta, and now the goal is to find VF. This is going to be so if I solve these equations for if I divide both sides of these equations by m1 plus m2, I'm going to use a different color here so that you can keep track of the different steps here. So I have m2 v2 over m1 plus m2. This is equal to vf sine theta. And on the second equation, I have m1 v1 over m1 plus m2 equals vf cosine theta. And now I'm going to square both sides of these equations. And now I'm going to add the respective sides. So on the left, I have m2 v2 over m1 plus m2 squared plus m1 v1 over m1 plus m2 squared, this is equal to VF. I'm going to factor the VF squared, so this is going to be sine squared theta plus cosine squared theta. This, as you know from trig, is equal to 1, so this is VF squared. Now, we have VF squared, so now I can plug this formula back into the conservation of energy equation, and with it, I can solve for the unknown W. I know what M1, V1 are, and I found out what VF is. I can solve for W now. So if I solve this equation for W here, so W equals 1/2 M1 V1 squared plus 1/2 M2 V2 squared, and then minus 1/2, what was it? Oh yeah, that's right. 1/2 M1 plus M2 times VF squared. Now, VF squared, they have the same denominator, so I can add the numerators. So this is going to be M1 plus M2 squared, and then M2 V2 squared, and then plus M1 squared V1 squared. This cancels out with one of these. Let's see. So yeah, so this is just algebra at this point. Bear with me. It's almost done. So we have M1 V1 squared plus M2 V2 squared. This is over 2. And to make it the same denominator, I'm going to multiply this by M1 plus M2. So this times M1 plus M2. And let's see, this is minus M2 V2 squared, and then minus M1 squared V1 squared. And now I expand the numerator and I simplify. So the M1 squared V1 squared cancels with this one. And what's left is M1 M2 V1 squared plus M1 M2 V2 squared all over 2 M1 plus M2. And yeah, if I just simplify this a bit further, I have W equals 1/2 M1 M2 over M1 plus M2. And this is multiplied by V1 squared plus V2 squared. This is the work that is due to non-conservative forces. It's what eventually brings the cars to a stop after they collide. This is the formula for that. So I hope this video was useful. I hope you didn't get lost in any of the algebra here. But yeah, if you have questions, leave a comment below, and I will see you next time. Take care.